I was asked to look at or to go over this example I put up for the pCloud versus Dropbox example. So we're asking time value of money questions around this. Pen sucks. Time value of money. There we go. All right. Only problem here is my penmanship. So looking at these two services, these are two services that I use. I've got Dropbox, which I've had forever. And more recently, I got pCloud, almost mostly because I really like their pricing system. Um, Now, I've got their smaller package, which is, I think, a half a terabyte for life, which was, I think, 200 bucks, but that 200 bucks is sunk, and now on the margin, I just have this half terabyte of auto-synced storage through pCloud, which I like. I've paid for Dropbox in the past, and it's good, but I kind of don't like having to pay for it more and more. But just this thing was kind of lingering, this notion of these two different pricing models. So let's look at the math of it and actually compare it. So for the setup, I think I modified this a little bit. Yeah, I think one is Dropbox is 3 terabytes and pCloud is 2. It doesn't really matter, but basically we've got the one-time price, and then we've got the per year price. So we want to think about in what situation would they be equivalent. So if we've got a one-time price of $350, and then we've also got this option of, I'm just going to round it to $100 per year. Implicitly, if we're saying that these two are equal, then, well, let's see, what are we saying? Well, so if we're saying that this is a one-time payment that is equivalent to $100 per year, then this is basically like saying that if we take that $350 and we calculate the interest we get out of that $350, that it is in fact equal to $100. That's probably the simplest way to put that, which would mean R would be 100 over 350. That's what, 10 over 35. So that's less than a third. Something like that. What would that be? If we multiply this by 4 over 4, what do we get? We've got 40 over 35. That's by 3. Let's make it 3. I was aiming for something close to 100. So 30 over not quite 100, a little bit more. This will be 105. So this is a little less than 30% is the effective discount rate if this is the case, right? So it's the specific question I put up here. Based on these numbers and assuming the company doesn't really care which option you choose, what must their discount rate be? So if these two are equivalent, then basically it means they think getting the money up front is as valuable as getting $100 a year over a long period of time. Right? Now, that is kind of extreme, right? A discount rate of 30%, that's even high for a credit card interest rate. So that would basically make sense if you're an executive and you've got a bunch of corporate debt that is literally on a credit card. You are effectively giving your customers an incredible rate of return on their investment. Right? So I, as a customer, spending $350 a year to save or 350 bucks once to save $100 a year, I'm effectively getting an interest rate close to 30%, which is pretty good. Now, of course, it might also be the case that I only need this the one time, right? I'm going to use this program once to say run a conference, and then after that, I never need to use it again. And in a case like that, of course, I'm going to just buy it for the 1 year and not renew my subscription. So we're kind of making some assumptions in here, but we are using this basic time value of money math to make the comparison. So the follow-up interpretation question, does this seem like a reasonable discount rate? It seems pretty extreme to me. 30%, I could see a context. So pCloud, I think that they're a semi-established company. Dropbox for sure is. It would be really extreme for Dropbox to offer their services at these terms. Dropbox, since they've got an established business, how much should they be charging for a lifetime subscription for the equivalent of their $100 a year plan? It should be something closer to $1,000, right? And even there, they're giving you 10% return on investment, which is kind of a lot. What does this imply about our assumption that they don't care which option you choose? Well, given this setup, it looks like pCloud offering this price really does want you to pay up front. Why might that be the case? Well, again, it's implying for sure that they want money now more than they want money in the future. They expect that they have more uses, more productive uses for getting paid up front. And I guess probably what this really means is whatever their actual interest rate is. So let's call this R hat. Whatever their actual interest rate is something that might line up with the expected cost of running your account. So they've got some of my data on their servers, which means they're paying for electricity for those servers. And I think their servers are in Switzerland, so they're paying expensive European prices for electricity. So whatever their cost per year is, it's got to be in line with this. So let's say that their interest rate is, well, let's say 10% just to be easy. 10% would translate to 35. 0.1 for 10%. So if their cost per year is $35 a year for an account like mine, or really an account like this 2 terabyte account, then that is effectively saying that they think that getting the $350 a year up front is going to cover their expected average cost in the long run forever. Right? So maybe they expect it's $35 a year right now, and it's only going to get cheaper over time, which means that over time, having this $350 sitting in an account generating interest to cover your server fees is initially going to just cover the server fees. But as those costs go down, suddenly it's a new income stream. Right? So suddenly this interest growth in this top part, in the long run, it's kind of like they're setting up this business, offering some server space, but the long run game is to have a big pile of money that they can invest however they see fit, whether that be in this server space or in some other part of the economy. Now, this math is relatively simple for this question. I suspect you're also kind of looking for some more complex math, since this question I'm getting is during finals week, and you're worried about the section on the time value of money. So let's see, how could I manipulate this? Well, let me start by just laying out our basic math. Right? Future value equals present value times 1 plus r to the power of t. Which we can manipulate to get RV present value equals future value times 1 plus r to the minus t. Right? These are the same equation rearranged. I did have a question by email. I'll just go ahead and answer that question because it's related to this math of how do we think about the question about how this goes on forever, right? So we do have that version of the forever math over here. So if we're thinking about what is the present value of say, $35 a year forever, a payment that we're getting repeatedly, how might we manipulate this math? How might we use this math to answer that sort of a question? So here is one possibility. Let's say you've got this set up in a spreadsheet, or maybe you've got it set up in a program like R. Let me go ahead and actually set up something here. I'm going to switch over to my screen, and I'll create a new function. And this is going to, I know not all of you guys have seen R, but I promise it's not going to be too scary. So we're setting up a function that we're going to call PV, which is going to be a function, and it's going to take, we're just going to ask what's the present value of $1. Right? We're not even going to make it as complicated as asking about any particular future value. Well, I guess we are. We're saying the particular future value of $1. We're going to think about our interest rate and the amount of time. So how much is $1 worth t years in the future at a discount rate of R? That's just going to be 1 plus R to the power of negative t. Nothing too crazy. So if I say, what is the present value of $1 at 1% interest 1 year in the future, it's really close to 99 cents, right? So if you put 99 cents in the bank at 1% interest, in a year, you get $1, right? Nothing too exciting, but how about 100 years in the future? Even at a low interest rate like 1%, it's going to take only 37 cents to grow to $1 eventually. So how can we use this math to answer a question about what's the present value of getting $1 a year forever? Well, what we can do is, let's just stick with interest rate of 1% for now. So 1% at 10,000 years, our present value gets to be really small. At 1,000 years, it's still really small. 100 years, 37 cents, like we said. If we make this, say, 5%, that's pretty close to zero. So if we're asking a question about how much is $1 1,000 years in the future worth, well, the answer is not very much. So what if we want to know what is the value of $1 a year or $100 a year? And to get $100 a year, we just multiply this answer by 100. Right? If $1 is worth that much, $100 is worth 100 times that much. So what I'm doing right now, plugging in different time frames, is asking how far out do we need to go before the present value is really close to zero? Right? 1,000 years out, that's pretty close to zero. So in Excel, you'd be basically repeating 1,000 rows like we've done in half a dozen videos so far this semester. The way we might do it now, so we want to know what is the value of payments over time. We're again going to say R and T. So what we're going to do is we're basically going to say for some number, let's just say we start with a result called 0. At the end, we're going to return the result. And in between, we are going to be updating, right? We're just going to be adding up for different values, different values of t. So $1 1 year from now, we're going to add on to result. The result we're going to say is result, which is currently 0, plus we want the present value of $1 at interest rate R for time I, right, which is going to be 1, and then 2, and then 3, and then all the way up to t. So we start with result as 0, and then we're going to repeat, say, 1,000 times this process where we take whatever we start with and then we add on what is the value of $1 5 years from now, 6 years from now, 100 years from now, 500 years from now. We're going to keep adding that all on. And then we're finally going to return that total sum. So value payments over time, whoops, at 0.01 is our interest rate. That's 1%. Over 1,000 years, it's worth $99.99. So this is really close to something very similar to what we were looking at over here. So over here, this basic math is asking the question of how much money do you need to put away right now to generate some amount of interest rate some amount of interest payments every year at some interest rate. So at 10%, we put $350 away. We get 10% interest. Each year, we're getting $35, right? So each year, we start with $350. It grows to $385. We take away $35. We're back at $350. It's going to grow back to $385 the next year. And we can repeat that forever as long as we're still getting that 10% interest. Right? So as long as the financial system hasn't broken down entirely, such a contract is possible. And that would tell us that at 10% interest, a payment of $35 a year forever is worth $350. Now, let's go back to R and ask about what that looks like over here. So here we want to think about value of payments over time. We're going to fiddle around with R to see what happens. Right? So here, if we put in an R of 10%, if we're getting $1 a year at a discount rate of 10%, for 1,000 years, the present value is $10, which is pretty close to what we said. So let's take this. This is times 35. Right? So here I've got a number that matches up with the story I was just telling. Right? So like I was saying, this function is for $1, but we want to know for $35, same difference. So this is the value of a $1 payment every year multiplied by 35. This is the value of a $35 payment every year for 1,000 years at a 10% discount rate. And we get $350. If we wanted to make this match up with a value of $100, this is going to be what? 10 over 35. Oops. Did I do the math wrong there? 100 over 350. Be 10 over 35. Huh. Is that right? Whatever. This is... Oh, wait. No. This is the discount rate. All right. I'm confusing myself. Don't listen to me right now. Here's the long story short. So we've got two basic ways to approach this question. We want to know what's $1 a year forever worth. What we did here is we said, well, how about $1 a year for many, many years? And that is just we add up the present value of $1 for each of those years. If we go far enough into the future, one more year hardly matters. Right? So again, we look at the present value at a 10% discount rate 1,000 years in the future. What's $1 worth 1,000 years from now? If you can get a 10% interest rate, you're not going to find a bank that's going to take that deposit. That is 42 zeros, 41 zeros. It's 40 something zeros after the decimal times $1, right? So it's a billionth of a billionth of a billionth of a billionth of a dollar. It's a tiny, tiny value. It's almost nothing, right? So strictly speaking, it is something, but if we keep adding past 1,000 years, we're going to be adding on top of 350 or on top of 10, we're going to be adding effectively nothing. Right? So the value of the payments over time, we are taking that interest rate and we're just calculating it by brute force. Right? We're just asking for a bunch of years. And that's approximately correct. It was a little further off at a low interest rate, but at a higher interest rate, what this number is telling us is that if you put $10 in the bank at 10% interest every year, you would have $1 worth of interest payments, which is exactly like the logic we saw on the paper. Right? We just found it the hard way. Right? Hard in terms of effort, but low effort in terms of thinking things through. We didn't have to change the question. We just used the math we got here. All right, that was kind of a rambling take on this overall question here. The P-Cloud versus the Dropbox. Long story short, for the final, for the time value of money section of the final, I want you thinking about both aspects of this problem. In both cases, the math is relatively simple, but it's a matter of sort of wrapping your head around it enough that you feel comfortable, going back and forth between this many payments forever. We're asking the question of how much interest do we need to earn versus for a one-to-one mapping, right? For some value in some year, we're using this bit of math here. All right, well, thanks for the questions. Keep asking them. This video dragged on longer than I'd hoped, but thanks for sticking with me if you're still here.